All right, you have an electronics project and you want it to be able to see, or at least be able to tell the difference between day and night. What do? You use a light sensor. So in this video, I'm going to show you two different types of light sensors. So let's get started. Okay, here they are. Here's the first one. This is a phototransistor, and I think you can think about this as an LED, a light emitting diode that works in reverse. Instead of passing a current through it to make light, when light strikes it, it generates a current. All right. And this is a photoresistor or a photocell. When light strikes it, its resistance decreases. So when it's in the dark, it has a lot of resistance, and when it's in light, it has just a little tiny bit of resistance. All right, well, let's what should we start with? Let's start with this one. This one's easier to hook up, I believe. So we'll start with a photocell or photoresistor circuit, and I will build the circuit and then write a sketch that makes it work, and then we'll switch gears and we'll look at the phototransistor and build that circuit and write some code that makes it work. All right, let's do it. All right, so here's the photocell circuit hooked up to the Arduino, and I built a circuit like this before. What we have is power supplied from the 5-volt pin on the Arduino via the white wire, and then a 10K resistor hooked up in series with the photocell, and then the yellow wire takes us back to ground. So we have two components in series here. It's a voltage divider circuit. The voltage is shared between the resistor and the photocell, and we can monitor how much voltage is being supplied to the photocell using analog pin via the orange wire here and using an analog read. So again, the way this thing is going to work, when the intensity of light increases, its resistance drops, which means it's going to use less voltage, and we should be able to measure that. So there's an inverse proportionality here. More light, less voltage. We should get a smaller reading on the analog read. Less light, more voltage, so we should get a higher reading on the analog read. All right, so I'm going to go over to the IDE now and write a sketch that makes this thing all work. So here's an empty sketch. I've already have the setup and the loop function laid out for me, and let's make this thing work. So the first thing I want to do is let's begin serial communication so we can view what the analog pin is reading, and then down here we'll just do a print serial print line analog read on analog pin 5. So we'll just read the analog pin and just print it directly to the serial monitor so we can see what's going on, and then we'll only do a read every 500 milliseconds. So it's compiling, uploading. Got to select the correct port. Uploading. Done. Okay. So if we look at the serial monitor, we're getting a small number. If I shine light on the cell, we get an even smaller number. If I cover the cell with my finger, we get a larger number. So less light, a higher analog read, because the photocell is using more voltage. More light, we get a smaller value on the analog read. Okay? So the data that's coming in here is inversely proportional to how much light is shining on the photoresistor. All right. So that's how you use the photocell and make an easy voltage divider circuit and to measure light using the photocell. So let's turn our attention to the phototransistor now. All right, I'm back here in the Arduino IDE, and I'm running exactly the same sketch as I was before. And it's essentially the same circuit. Let's open up the serial monitor and see what's going on. So I'm getting data streaming from the analog read, about 340, and if I shade the phototransistor, the value drops. So at first pass, it looks like the phototransistor is working exactly like the photocell. I get a smaller analog reading when there's less light, when it's darker. But you got to be careful here, because actually I switched the order of the components. Now when current flows out of the Arduino, it flows through the phototransistor first. So the voltage we're reading is actually the voltage that's being used by the resistor. So this tells us that when we cast some shade, the resistor uses less resistance. The phototransistor is actually using more voltage now. And when we have more light, the phototransistor is more conductive. So there's more voltage left over for the resistor. So it's actually working backwards. All right, so that concludes this lesson. 2 light sensors. Light sensors are very handy things to know how to use, and they come in handy for a lot of different applications in physical computing. All right, until next time.